Let's take a look at some properties of the convergence of a power series. If we have a power series defined by the sum from n equals 0 to infinity of c sub n times the quantity x minus a all raised to the n power, then it must satisfy one of a few conditions. The first condition states that the series converges only when x is equal to a. In this case, we would notice that the x minus a term would become 0, and therefore the whole series would be 0. The second condition states that the series converges for all real values of x. This one is pretty straightforward in saying that no matter what value of x we choose, the series is going to converge. The last condition is a little more involved. This condition states that there exists some real value r that is greater than 0 for which the series converges when the absolute value of x minus a is less than r, and the series diverges when the absolute value of x minus a is greater than r. For this condition, it is important to note that the absolute value of x minus a may equal r. If this is the case, the series may either converge or diverge. Let's see how these conditions might apply to an example. In this problem, we want to determine the convergence of the sum from n equals 1 to infinity of x minus 3 all to the power n over the quantity n to the n times e to the minus n. We have n in both base and exponent, so let's try the root test. We'll start with the limit as n goes to infinity of the nth root of the absolute value of a sub n. Inserting a sub n and noting that every term is raised to the nth power, we have limit as n approaches infinity of the absolute value of e times the quantity x minus 3 all divided by n. This quotient is raised to the power n, and the entire quantity is raised to the 1 over n power. The powers of n cancel, and we have the absolute value of e times x minus 3 times the limit as n approaches infinity of 1 over n. Taking the limit yields 0 for all x. Therefore, the original power series converges for all x.